Hello everyone. So in this video, I'll be discussing MME past year of 2022, and we have already done the past year of 2023. I have already uploaded this, and I've uploaded the important topics for MME as well. So part 1 of this has been uploaded, which consisted of the first 3 questions. Now I'll upload the part 2. So this would be the part 2 where we'll be solving the next 3 questions. So these past years would give you a rough idea about how you are supposed to approach in the exam. Also, since you have your exam on 10th, I'll try to upload it on 10th itself, on 9th early morning. And for stats, I'll upload 2 past years of 2022 and 2023. So they would be uploaded around 10th or 11th. So you would have ample time to complete them. Okay. Now starting with the fourth question, first part. If f is a continuous function on the interval 0 to 1, then prove that with f of 0 greater than 0 and f of 1 less than 1, then there is some number c belonging to 0, 1 which satisfies f of c equals to c. Okay, so you can use the intermediate value theorem here. And a better and a more specific way is, let's suppose gx be defined as a function which is fx minus x. So g of 0 would be f of 0 minus 0, which is f of 0 only, and it is greater than 0. So g of 1 would be f of 1 minus 1. Since f of 1 is less than 1, so this would be less than 0, because this is less than 1. So something less than 1 minus 1 would be less than 0. So what we have is g of 1 is less than 0. So with the help of the intermediate value theorem, we know g of 0 is greater than 0, g of 1 is less than 0. So the function would look like this. Suppose this is 0, this is 1, g of 0 is positive, this is negative. So there would be at least one c such that g of c equals to 0. G of c equals to 0 means this is g of x, so g of c would be f of c minus c is 0. This means, okay, this is getting very hodgepodge. Okay, so f of c would be equal to c in this case. So this is what we were supposed to show. Okay, so now moving to the next part. Suppose that the value of wine Wt is given as the following function of time. Wt equals to 1000 into e to the power 10 by 4 under root in crore of rupees. So t equals to 0 denotes the present. Sorry. And at an interest rate 10% compounded continuously and assuming 0 storage cost, what is the optimum time to sell the wine? Interpret the first order condition. So firstly, the present value of the wine would be, suppose we define it as ft. So the present value of the wine would be this is nothing but, if you define the present value, it is, suppose a equals to k e to the power minus rt. This is the discounted. This is because of continuous compounding. So this value is being falling with minus 0.1 t. Now you know this. Now you're supposed to find the optimum time to sell the wine. So you should know for the stationary point that you will get. So at this particular time you will be able, the value of the wine would be maximum. So f dash t would be, it would be 1000 into e to the power t by 4 minus 0.1 t whole thing multiplied by the derivative of this thing. So this would be 1 by 4. So this would be 1 by 2 into, this would be 1 by 4 into t by 4 to the power minus half into 1 by 4, because this t by 4, derivative of this t by 4 into 1 by 4 minus 0.1. So this should be equals to 0 for the first order condition. This term is always positive, so this cannot be 0. So we are left with this term. So this should be, this particular term should be 0. This would be 0 when, so this is 1 by 2 4 by t power half to 1 by 4 equals to 0.1. So this would become 1 by 2 into 2 by t to the power half, 1 by 4 equals to 0.1, t cancels out. So t to the power half equals to 1 by 0.4. So t to the power half becomes 2.5. So t becomes 6.25. So after 6.25 years, the value of the wine would be maximum. So this is the first order condition. You need to show that f double dash t is less than 0 when t is 6.25. So if it is less than 0, then it would show that after 6.25 years, the value of the wine would be maximum, and then it would make sense for the person to sell the wine. Okay. Interpret the first order condition. So the first order condition is this thing only. So the interpretation would be same only. So yeah, I guess the interpretation would be same only. Okay. Now moving to the next part of the question. Let fx equals to half log 1 plus x by 1 minus x. Does the function have an inverse function g? Now you can show that if f dash x is greater than 0 for all x's, or f dash x is less than 0 for all x, then we can say the inverse exists. But x cannot be equal to 1, because in that case the function would not be defined. Similarly, and if x is greater than 1, so the denominator, this would be positive only, but the denominator would become negative, and log negative something is not defined. So x cannot be greater than 1. So what we have is x needs to be less than 1. It cannot be equal to 1 as well. Similarly, if x is, okay, so log 1 plus x, 1 minus x, if x is minus 1, we will have log 0 upon 2. Log 0 is not defined. So the function is not defined at x equals to minus 1. At x equals to 0, this would be log 1 by 1. So which is log 1, which is 0. So it is defined. But for x less than minus 1, what we have is, suppose let's take value minus 2. f of minus 2 would be 1 by 2 log 1 plus x. 1 plus x would be 1 minus 2 is minus 1 upon 1 minus of minus 2 is 3. So this is also not defined. So the function is defined for the values of x which lies between minus 1 to 1. Okay. Now this is the domain of the function. This is the domain of the function. Now if let's find f dash x. So if the slope is, the function is continuously increasing, then, or continuously decreasing, then an inverse would exist. This is the theorem that we have already discussed in classes. Okay, now f dash x would be 1 by 2 into 1 upon 1 plus x upon 1 minus x, because the derivative of log x is 1 by x into dx. Okay, so 1 by this whole term and then the derivative of this term itself. So first function, derivative of first function, which is 1 into derivative into the second function minus derivative of second function, which is minus 1. Minus of minus 1 would be plus into 1 plus x upon 1 minus x whole square. So we have this. So if we simplify this, this would become half into 1 minus x upon 1 plus x multiplied by 1 minus x plus 1 plus x. So x would cancel out. We are left with 2. 1 minus x square. This cancels out. 2 cancels out. So we are left with 1 upon 1 plus x into 1 minus x. So this is nothing but a plus b into a minus b, which is a square minus b square. So this is 1 upon 1 minus x square. So f dash x is coming out to be this. And now since we know x belongs in the range minus 1, the domain for x is minus 1 to 1. So this term would always be positive, because 1 minus x square, this is always greater than 0 if x lies strictly in the interval minus 1 to 1. So this would be positive. So the whole term would be positive for all values of x belonging to minus 1 to 1. So we know the inverse would exist for this function. If yes, find the inverse. Now we are supposed to find the inverse. Okay, I'll just... Okay, now what we have is okay, now we are supposed to show that we have already shown that the inverse exists. Now we need to find the exact value of the inverse. Firstly, y equals to half log 1 plus x upon 1 minus x. So 2y equals to log 1 plus x upon 1 minus x. So now taking exponential both sides, e to the power 2y and e times log equals to e times log 1 plus x upon 1 minus x. So this becomes 1. So e to the power 2y equals to 1 plus x upon 1 minus x. On simplifying, minus e to the 2y into x equals to 1 plus x. Now we'll simplify this in such a manner that x equals to a function of y we get, so that this would be the inverse. So we have e to the power 2y minus 1 equals to x into 1 minus e to the power 1 plus e to the power 2y. So this would be, x would be equals to e to the power 2y minus 1 upon 1 plus e to the power 2y. So this would be the inverse of the given function. Okay, now we have found the inverse. Now we are supposed to find g dash of 1 by 2 log 3. So this is the value of y, which is fx. So we'll get value of fx as this when this term is equals to this. So half log So 1 plus x by 1 minus x should be equals to 3. So 1 plus x should be equals to 3 minus 3x. 4x equals to 2. So x equals to half. So for x equals to half, we'll have the image this half of log 3, and this would be then equal to 1 upon f dash 1 by 2. This is the formula. You must know this by now. Okay, even if you don't know, now you will be able to remember it. Now f dash was 1 upon 1 minus x square, I guess, x square. So f dash 1 by 2 would be, this would be equal to 1 by 1 minus 1 by 2 whole square. So this would be 1 minus 1 by 4, which is 4 minus 1, 3 by 4, 4 by 3. So the final value would be f dash 1 by 2 is coming out to be 4 by 3. So this would be equals to 1 upon 4 by 3, which is 3 by 4. Okay. So now moving on to the D part. Given f and g are not differentiable functions, show gx equals to f of ax plus b, where a and b are real numbers, is convex if fx. So we need to show that g is convex, which is given by this, if it is given that f is convex. So if f is convex, I'll start from the top. So if f is convex, we know one thing. If f is convex, then for all x1, x2 belonging to the interval for which the function is defined, there exists a lambda, which is, so this is the basic definition of a convex function. If you will write this as well, you will get marks. Lambda x1 plus 1 minus lambda x2, this should be less than equal to lambda f of x1 plus 1 minus lambda f of x2. This is the definition of a convex function. Now g of our function is given to us as this. Suppose we take x equals to lambda x1 plus 1 minus lambda x2. So this would be equal to f of a times x. So it would be a times, and our whole x is this thing. So it would be, I'll just erase this as well. Okay, so this would be times lambda x1 plus 1 minus lambda x2 plus b. So far this is clear. Now this becomes equals to f of a times, just expanding this, lambda x1 plus a times 1 minus lambda x2 plus, now we are manipulating this. So this is lambda b plus 1 minus lambda b. So you can see lambda b plus 1 minus lambda b is nothing but lambda b plus b minus lambda b. So this is b only. Okay. So this is equals to f of lambda times ax1 plus b plus 1 minus lambda times ax2 plus b. This is f of, and this f of lambda a plus lambda b. Now look at this. This is always less than equal to lambda f of ax1 plus b plus 1 minus lambda f of ax2 plus b, which is nothing but lambda g of x1. This is g of x1 plus 1 minus lambda g of x2. So we have shown that g would be a convex function as well. Okay. Now moving to the fifth question. The graph of the equation x square y minus 3y cube equals to 2x passes through the point xy minus 1 comma 1. Find the slope of the graph at this point. Slope will use implicit differentiation. So it would give us 2x into y plus x square into y dash minus 9y square into y dash equals to 2. Taking y dash to the one side only, y dash x square minus 9y square equals to 2 minus 2xy. So y dash is 2 minus 2xy upon x square minus 9y square. So this is the slope, and the points are minus 1 comma 1. So y dash at minus 1 comma 1 would be 2 minus 2 into minus 1 into 1 upon x square is minus 1 square minus 9 into 1 square. This would be plus 4 upon 1 minus 9, 4 upon minus 8, which is minus half. So the slope would be minus half at this point. Find the points where function is not differentiable. So the derivative is y dash. This won't exist when the denominator becomes 0. So when x square equals to 9y square, for all values of x and y such that x square equals to 9y square, there won't exist, the function is not differentiable. Okay, now we are supposed to find the horizontal tangent. Horizontal tangent is like this to the function. Suppose the function is like this only. So at this horizontal tangent, del y by del x, the slope is 0. So basically y dash is 0. Y dash is 0 when 2 minus 2xy equals to 0. So 2 equals to 2xy. So this gives us xy equals to 1. This implies y equals to 1 by x. So at this, when y equals to 1 by x, we have a horizontal tangent. Okay. Now moving to the next part of the question. Okay, we have done A part of the fifth question. This for 2 marks, 2 marks. The graph of the equation, okay, we have already done this. Find the limit 2 plus 3x to the power m, 1 minus x to the power n, where m and n belongs to natural numbers. Now, when x approaches infinity, this term would approach infinity and this term would approach minus infinity. So we have the form minus infinity to minus infinity. So we will use L'Hopital rule. This suggests that, so we'll take x to the power m common in the numerator and x to the power n common in the denominator. So we would be left with 2 by xm plus 3 upon 1 by xn minus 1 as limit x approaches infinity. Now this would be x m minus n 2 by xm plus 3 1 by xn minus 1 limit x approaches infinity. If looking at this m minus n, if m minus when n is greater than 0, which means if m is greater than n, then even if you don't care about this term would approach towards infinity, because x to the power something positive will approach towards infinity. Okay, now so this would approach infinity, so we say the limit does not exist. Okay, now when m equals to n, So this thing would become 1. So the limit in that case would be, this term would approach towards 0 because the denominator is approaching towards infinity. This would approach towards 0. So the limit would approach towards -3 in this case. And in the other case, when m minus n is less than 0. So we have x to the power minus something, minus, suppose y. This would be 1 by x to the power y. And if, so we will have something like, the limit would be like 1 by x to the power y into 2 by xm plus 3, 1 by xn minus 1. So if this is less than 0, this would mean this term, as x approaches infinity, this term would approach infinity and whole of this would approach 0. Okay. Now moving to the next part. We are supposed to do this as well. Okay. Let fx equals to log 1 plus x by b minus log 1 minus x by q whole divided by x, where p and q are positive constants. Can you define fx at x equals to 0 so as to make the function continuous at x equals to 0? So at x equals to 0, this would become 0, this would become 0. So log 1 is 0 minus this is 0, so this would become 0, 0 minus 0. So we are having the form 0 by 0. So we'll use the L'Hopital rule. So you will differentiate the limit as x approaches 0. You will differentiate the numerator and the denominator. Denominator you will get 1. On differentiating the numerator, you will get 1 upon 1 plus x by p into 1 by p minus 1 upon 1 minus x by q into minus 1 by q. On solving this, we'll have 1 upon 1 p plus x upon p to 1 by p. So p cancels out, minus 1 upon, so limit as x approaches 0, 1 upon 1 q minus x upon q into 1 by q. So q cancels out. Minus minus would become plus. So we are left with 1 by p plus x plus 1 by q minus x. Limit as x approaches 0. So if x approaches 0, this would become 0, this would become 0. So we are left with 1 by p plus 1 by q. So this can be written as q plus p into p by q. So if we define f of 0 as equals to this, then we can say that the function would be continuous at x equals to 0. Okay. Moving on to C part. Okay. Consider two cash flows A and B. For cash flow A, you receive 10 every year for 5 years, with the first payment being a year from now. This means that it would be discounted as well. So cash flow A is giving you 10 for 5 years. Okay. For cash flow B, you receive X every year forever, with the first payment being today. Okay, so in B, you are having X every time, but it would be discounted. What is the value of X so that cash flow B has the same present value as cash flow A, given that the rate of interest is 6% compounded annually? So this would be the present value for A till 5 years, 0.06 to the power 5. For B, it would be X upon 1.06, then 1.06 square till it will keep on going. B, you receive X everywhere forever with the first period being today. So there is no discount here. Well, it is starting at today itself. So this is like an, okay. For this, A upon R, 1 minus 1 upon 1 plus R to the power N. So this would become 10 upon 0.06 into 1 upon 1 minus 1.06 to the power 5. This would be the net present value of A. Okay. Now look at this formula. And for B, this is going for an infinite time period. So if N is infinite, this whole term, since R is positive, this whole term would be infinite. So 1 upon this term would be equal to 0. So for a perpetual time period, this would be his return. And in the initially he is getting X. So B would get X plus X upon R. R was 0.06. So this is the net present value of B. And this should be equals to the present value of A. So you can use the calculator to find the value. Okay. Now moving to the second part of the question. If fx and gx are differentiable functions of x, express the elasticity of hx equals to e to the power fx into gx with respect to x in terms of, okay, so basically this is given that both the functions are differentiable, so hx would be differentiable as well. So we are supposed to find the elasticity with respect to x of hx, and we are supposed to transform in the form of elasticity of f with respect to x and elasticity of g with respect to x. Okay, so taking log transformation would make it log hx equals to fx into gx. Now if we differentiate it, del log hx by del log x with respect to log x, we have f of x first function into derivative of second, g of x by del log x plus del f of x del log x into g of x. So this is the 1% change in hx as a 1 if x changes by 1%. So this is elasticity of h with respect to x. So this can be written as f of del g by del x plus and look at this for log x, del log x by del x would be 1 by x. So del x by del log x would be equals to x. So this whole term would be equals to x. So we have f of, suppose we take g, we multiply and divide it by g, and we multiply and divide it by f. So we have f of g del g by del x into x by g plus g f del f by del x into x by f. So we have got this. So taking fg common, we have elasticity of x with respect to g plus elasticity of x with respect to f. So this is the elasticity of x with respect to h. Okay. Now moving on to the next question. Looking for some space. Now qd equals to fp plus t. Qs equals to g of p, which is a function of price, where f and g are differentiable functions with f dash less than 0, g dash greater than 0. Use the equilibrium condition qs equals to qp to find an expression for del p by del t. Okay, at equilibrium we know qd equals to qs, so which means f of p plus t should be equals to g of p. On differentiating, we have f dash p plus t into del p by del t plus del t by del t. So this is equals to g dash p into del p by del t. Now del t by del t is 1. So we have f dash p plus t del p by del t plus f dash p plus t into 1 equals to g dash p into del p by del t. So del p by del t would be, okay, so I'll just write it here. So now del p by del t into f dash p plus t minus g dash p equals to minus f dash p plus t. So del p by del t would be equals to minus f dash p plus t and minus of g dash p minus f dash p plus t. So this minus minus would cancel out, so we are left with f dash p plus t upon g dash p minus f dash p plus t. Now we know that f dash is less than 0. So the numerator is less than 0. And g dash p is greater than 0. This is less than 0. So we know that this is positive and minus of something negative would be positive. So the denominator is positive always and the numerator is negative. So del p by del t is less than 0. Okay. Also comment on its sign. We have already commented on its sign. Find the expression for del p plus t by del t. So del p plus t by del t would be del p by del t plus del t by del t. So this would be 1. So we have this, we'll add 1 to it and find its range. So it would be f dash p plus t upon g dash p minus f dash p plus t plus 1. So we'll have f dash p plus t plus g dash p minus f dash p plus t upon g dash p minus f dash p plus t. So this cancels out. So we are left with this, and g dash p is greater than 0. We know this would be greater than 0 and this is also greater than. So this is less than 0 with a negative sign. So negative negative would be positive. So g dash p, so this whole thing would be positive only. It would be 0 when g dash p is 0. But since g dash is strictly greater than 0, so it would be greater than 0. And since and only in the case when f dash p plus t is 0 will this term become 1. And in all other cases when f dash p takes negative value, so g dash p plus minus of something minus would give you a larger value than compared to the numerator. So it would always lie between 0 and 1. Okay. So we'll move to question 6. I've already done this question 6 in one of my videos, but okay, I'll do it again. The monopolist with the cost function. So this is the cost function of a monopolist. Total cost function is half x square. In this case, total fixed cost is 0. This is the total variable cost as well. Okay. Faces the demand curve. Demand is 12 minus P. Find the equivalent price and quantity. For the monopolist, MR equals to MC is the equivalent price. Is the equivalent optimum bundle at which he'll maximize the profit. And the second condition is MC should be greater than MR. Now profit is total revenue. Total revenue is price into X. So price is 12 minus X. This is the inverse demand function. So 12 minus X into X. This is the total revenue minus total cost. This is the profit. Del pi by del Q. Del X. This would be 12x minus x square minus half x square. So this would be 12 minus 2x minus x equals to 0. So 12 equals to 3x. So x equals to 4. So the monopoly quantity is 4. And the price would be 12 minus 4. So the price for monopoly is 8. Okay. Now, what would the equivalent price and quantity if the monopolist is forced to take the price as given under perfect competition? So, for perfect competition, profit maximizing condition is price equals to MC. So, we have 12 minus X equals to MC. MC was marginal cost, which is the derivative of this. So, this would be 2 times X by 2. So, this is equals to X. So, 2X equals to 12, X equals to 6. So, for the perfectly competitive firm, quantity is 6, price would be 12 minus 6, so price is coming out to be 6 as well. Compare the profits under the monopoly and perfect competition. So for the perfect competition, so before that it is expected that the monopolist would be able to earn a higher profit. Okay, so for the perfect competition, the profit is price into quantity, 6 into 6, 36 minus cost, half into 6 square. So this is 36 minus 36 by 2, which is 18. So 18. This is for perfect competition. For monopoly, the price is 8. 8 into 4 minus half into 4 square. 4 is the quantity. So 32 minus 16 by 2. This is 8. 24. So the monopolist is earning a higher profit level. Okay. Now coming to the C part. To the third part of the same question. To ensure that the monopolist acts like a perfectly competitive firm, a specific tax of T per unit is imposed on him. Find the equivalent output T and show that it is actually negative. What does this imply? So if, okay, now with the imposition of the tax, per unit tax, specific tax, so which is a per unit tax only, so the profit would become, the total revenue would remain same, whereas the cost would increase by Tx. So del pi by del x would be 12 minus 2x minus x minus t should be equals to 0. So 12 minus 3x should be equals to t. And now, since we want the monopolist to produce the output level of the perfectly competitive firm, which was 6. So he should produce 6. So the taxes are coming out to be minus 6, which means the government is not actually taxing the monopolist, but they are providing him the subsidy so that he's able to produce more and produce more to the level of the perfectly competitive firm. Okay, so we are left with 2-3 more questions. I'll just take a break of 2 minutes. We'll start with B part. We are left with 2 more parts. I'll try to wind it up quickly only. Okay, now moving to the B part. First B, question 6 B part, first part. Let the function fx equals to 6 minus x square into under root x square minus 4 be defined over this. Find the extreme points of f. So to find extreme points, we need three things. First, the point where the function is not defined. Second, the points, the end points. And third, the stationary points. So you need to find the value of the function at minus 6. You need to find the value of the function at minus 2. And since it is a continuous function which is defined in the, so look at this. So this is a closed interval. So the function is defined over a closed interval, closed and bounded interval. It would have an absolute maxima and a minima because it is defined in an open and because it is defined in a closed and bounded interval. Okay, so you need to check for f of minus 6, f of minus 2. I'm not telling you the values. You need to find it on your own. This is easy stuff only. And then f dash x needs to be 0. And then you will get a stationary point with the help of this as well. And with the help of the second derivative, you can tell whether it would be a point of maxima or minima. Okay, so f dash x in this case would be, we will use the product rule. So the first function, derivative of first function, which is minus 2x. Okay, I'm looking for some space. Okay. So the derivative of this function would be minus 2x, derivative of first, into the second function, plus the first function into derivative of second, so which is 1 by 2 x square minus 4 to the power minus half into 2x. So this will cancel out. So this is okay. So if we take 1 by x square minus 4 common, okay, if we take the under root common, so we have minus 2x. If we are taking the under root common, multiplying it by numerator, so we will have x square minus 4 in the denominator, in the numerator, plus 6 minus x square into x, because this term would go in the denominator. So we have 1 upon x square minus 4 minus 2x cube plus 8x plus 6x minus x cube minus x cube. So this would be f dash x is this. So this is coming out to be 1 upon x square minus 4 minus 3x cube plus 14x. The denominator cannot be 0, right? So the numerator needs to be 0. So it would happen when x equals to 0, or if we take x common, minus 3x square plus 14. So either x equals to 0 or minus 3x square plus 14 equals to 0. 3x square equals to 14. X square equals to 14 by 3. X equals to plus minus under root 14 by 3. And since okay, and we had x equals to 0. Since 0 does not belong to this interval, we won't check it. Since root 14 by 3 does not belong to this interval, we won't check it, but we will check it for f of minus under root 14 by 3. And then you will check all these values and you will get the absolute, the global minima or maxima for the same. Okay, now moving on to the next question, the second part. Determine the concavity convexity of the following function fx equals to this. So this is fairly basic question. You need to find f dash x. So f dash x would be 2, so e to the power 2x plus 4 e to the power minus x into 1, then derivative of 2x minus 4 into e to the power minus x. Okay, then you are supposed to find the double derivative. You can just simplify this and then use the double derivative, and if it is coming out to be greater than 0, you have a convex function, and if f double dash x is coming out to be less than 0, you have a concave function. So these are the calculations. You can do it on your own, and if you've these are basic calculation only, so you can do this on your own. The video is getting a bit longer. Okay, now the C part, or let's do the fourth part first. This is quite small. Determine the intervals of concavity convexity of the function gx equals to x to the power 4. So the function would be concave when g double dash x is less than 0. And it would be convex when g double dash x is greater than 0. So g dash x would be 4x cube minus 24x. G double dash x would be 12x square minus 24, so which is 12 times x square minus 2. So this would be greater than 0 when x square minus 2 is greater than 0. So when x is greater than 2, so which means x square greater than 2 means x lies between the interval minus infinity to minus 2 and union 2 to infinity. So when x lies in this interval, f double dash x, so if we less than greater than equal to, okay, this is, my writing gets really bad after a certain point of time. So this is strict convexity, this is convexity. So for x belonging to the interval minus infinity to minus 2 union 2 to infinity, the function is convex, and this would be less than 0 when x square minus 2 is less than 0. So when x square is less than equal to 2, which means x lies in the interval minus 2 to 2. So if it is okay, and what we can see is minus 2 and 2 are inflection points. Okay, now let's do the last part, C part. Let fx equals to x minus 2 times 2 log x plus 1. Determine where fx is increasing or decreasing. So you need to see f dash x equals to, when is f dash equals to 0, and then accordingly you can see the intervals where it is increasing or decreasing. So f dash x would be 1 minus 2 upon 1 plus x into 1. Yeah, so it is 1 plus x minus 2 upon 1 plus x. So this is x minus 1 upon 1 plus x. This is f dash x. So this would be equals to 0. Okay, so this term would be equals to 0 when 1 equals to 2 by 1 plus x. So 1 plus x equals to 2. So x equals to 1. So at x equals to 1, and it is not defined at x equals to minus 1, the slope. So we'll have the two intervals 0, 1, minus 1 till minus infinity, then infinity. Now let's take the value 0. We'll see whether f dash x is positive or negative. Okay, so this is the f dash x, 1 minus 2 upon 1 plus x. So when it is 0, f dash, so f dash 0 would be 1 minus 2 upon 1, which is minus 1, which is less than 0. So it is decreasing. at 0. At f dash 2 is, we have already formed the interval, so f dash 2 would be 1 minus 2 by 3, so which is 1 by 3, which is positive. So beyond 1 it is increasing, the function is increasing. And let's check for the interval. Suppose f dash minus 2, this is 1 minus 2 upon 1 minus 2, so this is 1 minus 2 upon minus 1, so 1 plus 2, which is 3, so it is greater than 0, so it is increasing in this interval as well. And you can check for this interval as well, it would be falling. Okay, now they are asking us to find possible extreme points and inflection points. So first thing is, f dash x is 0 when 1 minus 2 by 1 plus x is 0, so this is equals to this, 1 plus x equals to 2, so x equals to 1. At x equals to 1, f dash x equals to 0, so x equals to 1 is a stationary point. Now you can check at f double dash x. F double dash x would be minus of minus 2, so 2 upon 1 plus x square. And f double dash of 1 would be 2 upon 2 square, so this would be 1 by 2, which is greater than 0. So at x equals to 1, we will have a minima, because at stationary, like this was a stationary point and the second derivative is coming out to be positive, so we will have a minima. And since f double dash x is, so f double dash x is coming out to be 2 upon 1 plus x square. So for all values of x belonging to the real numbers, this is positive only. So the function is convex throughout. So there won't be any inflection point. Now for any global maxima or a minima, when x is approaching infinity, this term is also approaching infinity, so fx would approach infinity. And when x is approaching minus 1, so minus 1 plus 1, log 0 is not defined, which is log 0 is not defined, so which is approach, log 0 is infinite only, so this is not defined. So we can say that there does not exist any maximum value, but the minimum value, because the function is convex throughout, is at x equals to 1, which was the stationary point as well. Now last thing, we are supposed to sketch the graph of f of x. First thing, we know that at x equals to 1, we are having a local minima. At 0, when x is 0, look at the value of fx. When x is 0, this would become log 1, so this would be 0, this is 0, so we are here. And and at x equals to 1, we had a local minima, and the local minimum value would be 1 minus 2 log 2. It would be somewhere here. Okay, now and for so this function would not be defined at x equals to minus 1, because this would be 0 only. So it would be approaching towards minus 1, but it won't get towards minus 1. Okay, so since it's a convex function, it would be like this only. And okay, we don't we were we knew that it is a convex function because f double dash x is coming out to be greater than 0. This point we can calculate because at this point y is 0, so this is 0, which is equals to x minus 2 times log x plus 1. So x equals to 2 times log x plus 1. So we can solve this value for x. So this would be, this point would satisfy this thing. And so we are done with this paper. Okay. So all the best for your exams. Do well. If you have any queries, you can ask in the comment section. Also, I'll be uploading 2 more videos, 2 past years of PYQs of stats. I'll see when I get the time, but I'll do it because I've promised it to some of my students. So I'll do this. Okay. All the best.